potential energy. In this case, we want to find the change in potential energy gravitational, delta U gravitational. So, if I am moving this object from here to here at constant velocity, what is the external force on the object? What will be the external force acting on this object? My hand. So, my hand is what we call external to the object earth system. So if the system is object and earth, because remember, the potential energy is the energy due to the relative position between two particles. So what are the two particles here that create potential energy? The object and what else? The earth. If there are no two particles, we cannot have potential energy. We have to have potential energy if we have two particles. Energy due to the relative position between two particles. These are the two particles, earth and this. What is the meaning of potential energy? The word potential immediately said something. What is potential? You have potential to be a scientist. But something you have internally, and from here the word internal energy in chemistry used. Something you have. So if I put this here, what will happen? If I just release, what will happen? Goes down. Why? So goes down means that these have to have a certain energy, which the energy is brought by me to the object, moving up. I put the energy already, it's here. Energy is there. How do we know? If I release, this will move. That move because internally has certain potential. And from that the word potential energy. So the potential energy. So you can see. And that is what we are calculating now. The amount of potential energy I am transferring to this object. By definition, is equal to the work done by my force to move the object at constant velocity. So if I move the object at constant velocity, what will be my force? Equal to. What will be my force equal to? If I am moving an object at constant velocity, what will be my force? Zero. No. What is zero? Something is zero, but not my force. The net force. The net force is zero. The combination of all forces. And what forces are acting here? Gravity and my force. So my force will be equal to what? Mg. So my force is equal to mg. So what will be the work done by me? By definition, will be my force time delta y, time cosine of what angle? Moving this, like this, the displacement is this way. And my force is this way. What is the angle between my force and the displacement? Zero. So, what is cosine 0? 1. So, cosine 0 is 1. So, what will be the work done by my force? What is my force equal to? Mg. So, mg delta y. What will be the change in potential energy by definition then? Gravitational. What is a low altitude? The change in potential energy by definition equal to the work done by the external force. But the work done by the external force is my force. And this is the work done by my force against the gravity. So this is the definition from now on of change in potential energy what? Gravitational. This change in potential energy gravitational from now on will be mg delta y. So a low altitude. Why did I say a low altitude? Because gravity at low altitude is constant. If we go away from here farther, we need to consider that the gravity will change. And we will learn that later. Okay. So this is the first change in potential energy, gravitational. What can you see here? What can you see that with respect to the work done by the gravity? The work done by this conservative force. Between this general definition of work done by the gravity and this change in potential energy, what can you note? They are opposite. So the work done by the gravity is negative mg delta y, but the change in potential energy is mg delta y. So where do you think that there will be more potential energy? At this point or at this point? Here. And where the work will be more negative? Here or here? So the work is negative as we go up. The work, but the potential energy is the opposite. As we increase, this will have more potential. Got it? This is the difference. So from here we can just come to a very important definition of change in potential energy in general. Delta U is either the work done by the external force, or if you have the conservative force, will be negative the work done by the conservative force. The opposite. But because the work done, by definition, work, what is work? The integral. What is work? Negative is this negative. And what is work? The integral of the force. What is the integral of the force? The integral of the conservative force times what? Times the displacement delta x or dr in any dimension. Scalar product. This is very important definition. Delta U is equal negative the integral of the conservative force dr. But if I use the external force, will be positive, because the external force and the gravity always will be in opposite direction. So this is delta U. This is very important definition, which I will include here. What is potential energy? Delta U